we bring questions from the audience, I'm going to do two things. One is I'm going to talk about the poll results from what you guys presented, and then I want to make sure that I direct a question that I've been taking notes on to each one of the panelists who traveled a long way here, and I want to make sure that they have a chance to participate. So first of all, in the voting, 11 people responded, pretty good out of such a small group, and by a good margin, I think the unit-specific high-fidelity process simulator was rated as the most important. Perhaps that's a consequence of suggesting that this is simulators for high-consequence units, because high-consequence units, you really want to understand that chemistry and physics. The second most important simulation was control system simulation, then spatial geometry, simulation of operating procedures, on-the-job training, classroom training, and unplanned health emergency. I kind of threw that in once because I was at a plant site doing some consulting work, and one of the things that they executed at that time was man down. All right, and so they actually put a guy up on the second deck of a distillation column, pretended he just had a heart attack, and then they had to simulate bringing in fire trucks, ambulances, and how they got that guy down. But I would say it was very useful for those abnormal situations. All right, so let me start by directing a few questions. The first question is to Abhishek, and in Chris's presentation, they made some amazingly wide-ranging collections of simulation. They simulated APC, they simulated data historians, they simulated a lot more stuff than most. And I know that one of the questions I have is, when you simulate advanced process control, like model predictive control, like DMC or something, you have to do step tests on the process. Would you actually use the models that we created, the dynamic models? Are those models accurate enough that you could actually do step testing or optimization calculations on the models that were built in this case?
I can start by introducing myself. My name is Abhishek. I work in product management at Honeywell, Honeywell Connected Industrials specifically. And my focus is mainly around high fidelity process simulations, right? How can you use them? How can you basically take something from like the OTS simulations that you have? How do you run that against real-time data? How do you derive inferentials from it? How do you use it for optimization? APC gain updates, etc. Right? So that is my basically focus. So to answer your question, we can definitely use those high fidelity process simulations. I mean, they are already used for, let's say, like what Chris showed, like virtual commissioning, checkouts, etc. Right? So there is some amount of trust in it. There's a lot of detail into those simulations. And we can actually use that either in like a dynamic or steady state mode, right, to do various things. So one of the things that we are doing is basically using those simulations or the backbone, like the Unisim-based simulations, process simulations, to run that against real-time data and supply inferentials, right? Some kind of soft sensing measurements that are not readily available to the operators for making any decisions on like tweaking product quality or yields, right? Specifically in processes where GC measurements are not that reliable, etc. You could use actually these simulations against real-time data to kind of supply those soft sensors. For APC, we've used it for basically these simulations in like a steady state mode to kind of give gain updates, to kind of address non-linearities that APCs typically in like highly non-linear units. APCs do a good job, right? But for highly nonlinear units, for various changes in feed, etc., you run it through a high fidelity simulation against real-time data, and you can provide those gain updates to kind of correct, the APC performance. So we've kind of used it in various forms in this way. And I think Chris also kind of hinted at some of the applications of these training simulators, right, to kind of use it for inferentials again. And I think, many other companies are also using these high fidelity process simulations to even do optimization. So they'll kind of, run external programs in Python or, web, basically web-based stuff, right? So basically, use Python to kind of run some collect data, mark data for data sets for like, okay, this is a high quality data set. It's good enough for me to kind of send it to my simulation, and then run it against Unisim to basically generate data sets for optimization. So it's a very novel way of kind of using Unisim. So you're not kind of using it optimizing within Unisim design, but sort of using it as a data set generation, right? Because now you have this high fidelity simulation. So a lot of work is happening around kind of leveraging some of these simulations that already exist, right? And how can we use that against real time? How can we improve operations? How can we improve, the soft sensing capabilities that typically if you don't have sensors, right, in the
Yeah,
plant?
excellent answer. I might want to retract something I said earlier. I said all models are wrong, some are useful, but it really just brings to my age of my history. When I started my career, our models were very trivial. The digitalization transition has resulted in more and more precise and more accurate models. And the fact that we have the digital computation, we have the engineers, the tools to do this means that suddenly we can get a lot more mileage out of these models.
Yeah, and just to actually add a note to that, right? You're not completely wrong. I mean, all models are somewhat wrong, right? But I think we figured out, okay, what are the things we can do to sort of correct these models, right? Or at least highlight the fact that, okay, my model confidence or my model performance is 98%, right? So now, based on this, right now, the operator can make a sort of rational decision, right, on whether to act on that soft sensing value that's coming out of my simulator or just ignore it, right? So I think,
All right, great. Now I have some questions about, for Ron Lee, and I'd like Ron maybe to just give you a brief introduction of what you do for Vuvio. But when Gabriel put his presentation together, it was like YouTube for process, all right? It was like, uh, uh, dynamic street maps with, accentuated augmented reality type of things. There was a lot of new capabilities. So what do you do for Vuvio, and and how would you characterize some of the work that Gabriel has done at BASF?
Okay, thanks. Good morning. Yeah, my name is Ronald Lee. I'm Vice President of Operations for Vuvio. Prior to that, I retired with 36 years at DuPont. Um, the what Gabe showed was what we call enhanced reality to really differentiate it from the virtual reality space. And as you all know, a plant is no place to practice, okay? A plant that's running. That's not when you want people practicing. So we basically give them the real plant, okay? As it is in the field, the assets, you saw the broken valve handle. I'm a little bit embarrassed by that, but that's that real plant, okay? And so a big thing that we're seeing right now is that you can practice and learn remotely, okay? You don't have to necessarily be in the field. Also, self-paced learning. Everybody don't learn at the same pace. And I know a lot is talked about in terms of onboarding, but a big surprise, ha ha mama, is that a lot of those senior operators that you thought knew the operation really don't know it. And so what you discover is an old term we used to use called cowboying, okay? And what Gabe said is people started up differently. We find more procedures with ambiguity and people skipping steps or taking the wrong step. So when we go out with our forward engineers and take photo shots of your plant, and if you make a change, you can easily send us the photo. We can plug it into your replica and you're back running. You don't have to start from scratch. So that's a paid advertisement. But anyway, we find that operator A don't do it like operator B. And there's a lot that's not in the procedures, that's not written, that they have here. And guess what happens with all of the attrition? It goes right out of the gate. And we used to call it we lost our process. And we have all kind of analytics on the process, but it's that human asset that we fail to build. And we fail to recognize that where that human asset interacts or engages with the physical assets, that's a critical intersection. So we are all about building the human asset, giving them the most knowledge. We're in a lot of community colleges, and they love it, okay? But this is how people learn, okay? They learn different than I learn. So I don't know if I've answered your question, but that's the value of Vuvio. Knowledge transfer, knowledge capture, and allowing people to operate with the actual assets.
I think it's also important to note that as I watched Gabriel's presentation, when those senior operators failed and the junior operators passed, I'm not sure if that's the way it was, but there's a pecking order within operators. Senior, the junior operators are looking to the senior operators are saying, I'm the authority, I'm training all these junior operators. But as you mentioned, that it could be that maybe they need some work too. And but the fact that wherever the failures are for wherever they occurred is that because you're rating them and because you're trying to get them to pass, all of a sudden you are questioning, well, is it our training procedures that are wrong? Is it the operators that are wrong? Is there some device in the field that needs better labels or, whatever? And that's very important to update operating procedures. And operating procedures, they're hard to write operating. You need a skill set to operate, to write good operating procedures.
Yes. Yeah.
All right. Now, I have another question for Gil. Gil is from GSES. Can you describe a little bit about you and your company and what you guys do, and how the heck did you build this simulator for NewScale? How did that come to be? Maybe DOE was involved, and what are the different uses? Obviously, it's not just operator training. You use this for NRC regulatory approval, right? So obviously this simulator, I know for a fact that the nuclear industry has got some very sophisticated simulators, full nucleonics, reactions, meltdowns, every possible scenario you could imagine. And they also build what they call full-scale replica systems. That basically means they build an entire building with the exact replica control system, and they train operators and supervisors all at the same time in a separate a whole building dedicated. That's not done in the process industry.
Well, you know us well, so you pretty much described the company. Gil Grady, Senior Vice President of GSC in charge of business development. Background is I've been with the company almost 42 years, so I've done everything but write code. But kind of talking about, the company, we're mainly a simulation, engineering, and workforce solutions company. So here we're talking about simulation. So the NewScale was really an interesting project. They came to us, back in the early 2000s when they pretty much had a concept for the reactor vessel. If you were in yesterday's presentation, NewScale is kind of unique in its physical structure. It's got a containment structure, which is a steel tube that has a reactor and heat exchanger and everything you would normally see in a plant that kind of fills up this building. They've got in almost a single little unit. So they had that pretty well designed coming out of Oregon State, but what they didn't have was the rest of the plant. All the balance of plant, the turbines, the condensers, and everything else. So they came to us and they asked us if we could help build a simulator to help them make some design decisions. One, kind of test out the feasibility of the reactor core and its workings, but then start bolting on the rest of the plant to see how an integrated operation will be. So the plant's not designed, so typical simulator, somebody gives you a plant design and you go and you model it. In this case, there wasn't a plant design to model. So we ended up using our experience in building fossil plant simulators, smaller scale than a 1,000 megawatt nuclear plant, and kind of use that. And it was really an iterative process. So we first delivered something that was a very highly sophisticated simulation of the reactor core and the thermohydraulics associated with that, and then kind of more generic models around the balance of the plant. And they would use that to make some design decisions, sizing decisions on systems. And then we'd go through and they'd come up with a little bit more detailed design, and we'd reiterate and went through this process about 3 or 4 times until we came up with a more robust modeling of what the plant was going to look like. But then you talked about different uses of it. So that was kind of one use around the engineering design aspect and support of it. Others have talked about the typical uses of simulation. So control room design, we talked about that yesterday and today about how do you How do you operate 12 reactors without 48 people, in the control room and in that conduct of operations and the information that has to be presented, so all the human factors. So it was used to support that, used to support the procedures. Again, they were trying to minimize operator interaction with the plant and automate as much as they can. That requires procedures that needed to be validated in some way other than just walking through a piece of paper. Some unique aspects, though, were, they had to present to the NRC their design. So instead of it just being a paper-based design application, they used the simulator to allow the regulators to actually visualize what was happening in the design so they could see the plant running. So they didn't have to just rely upon engineering analysis and their experience, but they could actually get on the simulator and play with it and see that it's going to behave the way the paper design says it's going to behave. And then finally, it was a marketing tool. So again, you're trying to convince people to invest in NuScale as a company to design this reactor. You're trying to convince customers to buy a radically unique nuclear design. And if you can show them this is the plant and it's working and it's going to behave the way we think it is going to produce the power we think it's going to produce, it was just a fantastic marketing tool for them. So those are kind of the major uses and value they got out of the simulator.
Well, I think that absolutely shows the power and value of simulation. I mean, mathematical models can be used for incredible things in digitalization. So now we're going to take any questions we have from the audience. Just raise your hand and either get us a microphone. Microphone will come up. And just introduce who you are.
I'm here with Dow. I had a question specifically with BASF and then probably the Vuvio. So really cool, like the video demo and everything. What is for like a typical plant, like the time investment in developing all of that? Because that was quite a lot that was, on there. And then my follow-up question would be, as things change, as things are, improved upon within a plant, what does that look like? Because in my mind, I'm thinking, oh my gosh, that would be a person needs like a full-time job to help keeping that updated. What does that look like? I guess I actually have one more question, but I'll let you answer those first.
Okay, so as far as time investment, our first initial pilot, we had one shift supervisor that worked with me, and Vuvio brought in 2 or 3 forward engineers. So we initially started out with right at 19 different simulations, including replica, and we did 1, 2, 3, 4 enhanced views, and that took right at 4 days. So, but again, our procedures were correct. All right, they were correct. So once we completed the photo shoot, they send it off. It comes back to us for quality review. You're looking at a couple of days quality review, and then implementation. So you're not talking a whole lot of time investment. You don't need a whole crew of people. Again, I basically had one shift supervisor that ran the whole project. We would just check in the mornings, check in the evenings. So that's as far as time investment. And then your second question was, what was your second question? Oh, yeah. So again, with all the different processes we have in all of manufacturing, you got quality, you got PSM, you got MOCs. So these were big questions when we rolled this out. It's like, all right, so there's a change on a procedure. How do we make sure the simulation gets changed? So we've actually been able to link our Vuvio simulation to our document management system. So when we have a change, and we have to change a procedure, it's linked to Vuvio. So we lock that simulation out. So they can no longer use that simulation until it's updated. So, and to tell you how quick, when you're doing an MOC, so I would be the one updating the procedure. So if it's a simulation change, I can go out. If it's a small change, I can go out. I can take the pictures. I send them to Vuvio. And I've done this, and you're looking at probably anywhere between 24 to 48 hours turnaround, and you have the new replica, the new simulation. If it's a large change, then we would have Vuvio come back out and reshoot, some of the, photos, depending on how big it is. But the ones I've done here lately, it's small changes, valve or a pump or piping or something like that. And I pretty much take the picture, send it off to them, they send it back, and it's updated. And we put it back in service.
You know, when ARC first got a demo from Vuvio, one of our discussion comments was, at ARC, we've seen that there's been a lot of companies like Siemens and Aviva that have integrated their dynamic simulation, their control system simulation, and their 3D virtual simulation. And one of our suggestions to Vuvio, which they absolutely agreed with, is don't connect that, because that cost of making that connection from that 3D simulation to these other devices will kill your efficiency of economics. Does that sound correct, Ron?
Okay, and we're not trying to compete in that space. We are solely for this niche, this piece of the market, okay? And it's operator training, it's also skill maintenance training, because we're now simulating critical equipment overhauls and things. And Heather, the project duration is about 16 to 18 weeks total, okay? Thank you.
And then if I could ask a follow-up with that. So my emphasis is specifically functional safety, and then SIS. And so I wanted to know, and I hear you with, it's not with the control system, but there's impairment procedures, there's those sorts of things. And so I was curious if there was anything specific, any learnings that come out of that, or anything that maybe you guys might specialize in from like a functional safety standpoint, or from an SIS standpoint with that.
Yeah, when you say functional safety, you're talking about work practices or things like that, or?
No, more within the actual process itself. So the control system itself, right? A safety system would handle thing happening, but there's how do people interact with that control system?
Yeah, and the most we would do, because we're not tied in dynamically, is do some scenarios, different scenarios. What if conditions are this? What do you do? Okay, and that's based on your written procedure on how to respond to emergencies or upset conditions. Okay. Welcome.
All right, it's now 10 o'clock. On your VFairs app, if you go to auditorium and you find this session, there's a little survey about how you rate this particular session. We'd appreciate if you filled that out. Otherwise, thank you so much for coming to our session and coming to our ARC forum. It's fantastic to see so many people, and I guess my take is digitalization has definitely gotten more sophisticated. This is from somebody that started in a department called Analog System Design at Foxborough Company. All right, thank you.